Hello students, I am your Sir LOYAMBA coming with trigonometrical ratios of complementary angle. Trigonometrical ratios of complementary angles. So you must be wondering what is complementary angles. Yes sir, I have heard somewhere in class 6, class 7, I have forgotten what is complementary angles. So I'll just try to remove your confusion. The sum of the measure of two angles equals to 90 degree is called complementary angles. I repeat again, the sum of the measure of two angles equals to 90 degree is called complementary angle. Now you must be wondering, what is complementary angle to do with trigonometrical ratios? Yes, there is a very close relationship. Let me recall you again all the trigonometrical ratios again. I have already taught you that sine theta is equals to perpendicular by hypotenuse, cos theta is equals to base by hypotenuse, tan theta equals to perpendicular by base, cot theta equals to base by perpendicular, sec theta equals to hypotenuse by base, cosec theta equals to hypotenuse by perpendicular. So all these trigonometrical ratios we are going to apply with complementary angles. Now consider this triangle ABC as a right angle triangle. So ABC is a right angle triangle, right angle at angle B. Angle B is 90 degree. But we know that from the property of triangles, we know that angle A plus angle B plus angle C is 180 degree. So angle A plus angle B value is 90 degree plus 90 degree plus angle C equals to 180 degree. So angle A plus angle C equals to 180. Now take this 90 degree this side, 180 minus 90. So angle A plus angle C is 90 degree. So we come to know that the sum of the measure of two angles equals to 90 degree is called complementary angle. So this angle as A and angle C are complementary to one another. I repeat again, angle A and angle C are complementary to each other. So now if we take angle C on the other side, angle A is equals to 90 degree minus angle C. So I repeat again, angle C, if you take on the other side, angle A is equals to 90 degree minus angle C. So now we are going to see this from this right angle triangle, angle A and angle C are complementary to each other. So we find that angle A plus angle C equals to 90 degree. If we take angle C on the other side, angle A is 90 degree minus angle C. That means in place of angle A, we can write 90 degree minus angle C we can write. So now, if we measure this angle sine A, if we measure this acute angle, angle A, if we measure this acute angle, angle A, then this will be considered as perpendicular and this will be considered as base. And the side opposite to 90 degree is hypotenuse. If we measure this acute angle, then we are going to consider this one as the perpendicular and this one as the base. Remember once again I repeat, if you measure angle A, then BC will be considered as perpendicular and AB will be considered as base. If you measure this acute angle, angle C, then AB will be considered as perpendicular and BC will be considered as base. Hypotenuse remains fixed. So sine angle A is BC by AC, perpendicular by hypotenuse. Cos A equals to base by hypotenuse, AB by AC, AB by AC, base by hypotenuse. If we measure sine angle C, if we measure this sine angle C, then this will be considered as perpendicular, AB by hypotenuse, AC. Now, if we measure cos C, then it is cos C, this is perpendicular and this is base. So BC by hypotenuse AC. So now, as we see that angle A plus angle C equals to 90 degree, angle A equals to 90 degree minus C. So putting the value of A as 90 degree minus C, in place of sine A, I am putting sine 90 degree minus C. If it is sine 90 degree minus C in place of A, then BC by AC remains the same. So cos A equals to AB by AC. So in place of A, I am putting 90 degree minus C, AB by AC remains same. Now you see here, Sine 90 degree minus angle C is BC by AC, and here cos C is BC by AC. These two are same. Now cos 90 degree minus C is equals to AB by AC. Here sine C equals to AB by AC. These two are same. So therefore we can write that sine 90 degree minus angle C is equals to cos C. Then cos 90 degree minus angle C equals to 90 degree minus C equals to sine C. Similarly, tan A equals to BC by AB. Tan A, this is perpendicular BC, this is base AB. BC by AB. So cot A is also base by perpendicular, AB by BC. Now in place of A, we are going to put 90 degree minus C. In place of A, the value of A is what? 90 degree minus C. So tan 90 degree minus C is what? BC by AB. Now in place of A, we are going to put 90 degree minus C. Cot 90 degree minus C is AB by BC. But now, if we measure this angle, acute angle tan C, this is going to be perpendicular and this is going to be base. So AB by BC. Now if we measure cot C, this is perpendicular, this is base. So base by perpendicular, BC by AC. So what do we find now? Here you see AB by BC. That means cot 90 degree minus C is equals to tan C. So what we get here? Cot 90 degree minus C equals to tan C. Then tan 90 degree minus C, what do we get? Cot C. Now we see here similarly sec A. So this is perpendicular, this is base, and this is hypotenuse. So what is the ratio of sec A? Sec A is hypotenuse by base. So hypotenuse is AC and base is AB. Similarly like that, cosec A is hypotenuse by perpendicular. AC by BC. AC is the hypotenuse, BC is the perpendicular. So in place of A, we will put the value 90 degree minus C, that is ratio remains the same. Now in place of A, we will put the value of A 90 degree minus C, ratio remains the same. Now we find out sec C. So when we measure this angle, this becomes a perpendicular and this becomes a base. So hypotenuse by base. Cosec C. So since we are measuring this angle, this becomes perpendicular. So hypotenuse by perpendicular. Now what do we see from here? Sec 90 degree minus C is equals to cosec C. AC by AB. These two are same. So in place of sec 90 degree minus C, we can write cosec C. Similarly like that, cosec 90 degree minus C, with whom it is equal? Sec C. Here AC by BC, here AC by BC. So cosec 90 degree minus C is equals to sec C. So in that way, we get 6 ratios. So we get 6 relationship of trigonometrical ratios of complementary angles. I will say again, we get 6 relationship of trigonometrical ratios of complementary angle. Sine 90 degree minus A is cos A. In my previous one, it was sine 90 degree minus C equals to cos C. But here I am writing here sine 90 degree minus A, C, A, B, you can write anything. So sine 90 degree minus A equals to cos A, cos 90 degree minus A equals to sine A, tan 90 degree minus A equals to cot A, cot 90 degree minus A equals to tan A, sec 90 degree minus A equals to cosec A, cosec 90 degree minus A equals to sec A. Now, we are going to do exercise 8.3. So now we are going to do exercise 8.3. Exercise 8.3, question number 1. Evaluate sine 18 degree by cos 72 degree. Sine 18 degree by cos 72 degree. Keeping cos 72 degree as it is, let us convert sine 18 degree into sine 90 degree minus 72. 90 minus 72 is 18. So this becomes sine 90 minus angle A. Sine 90 minus angle A is cos A. So cos 72 remains a fixed. Cos 72 by cos 72 is 1. Similarly like that, we can do same sum in this way. Keeping sine theta as fixed, cos theta will be converted into cos 90 degree minus 18. This becomes cos 90 minus angle A. Cos 90 minus angle A is sine A. So sine 18 degree by sine 18 degree is 1. Whether you can do it in this way or in this way, it is same. Question number 1, number 2 is same with question number 1. So you can try now question number 1, number 3. Question number 1, number 3 is cos 48 degree minus sine 42 degree. So cos 48 degree minus sine 42 degree. Keeping cos 48 degree, I have converted sine 42 into 90 minus 48 is 42. 90 minus 48 is 42. So here it becomes sine 90 minus angle A. Sine 90 minus angle A is cos angle A. So here is cos 48, here is cos 48. So opposite in sine. So cos 48 minus cos 48 is 0. So similarly in the same way, this same sum I can do like this, cos 48 minus sine 42. Now keeping sine 42 constant, here I will convert cos 48 into 90 minus 42. 90 minus 42 is 48. So this becomes the formula of cos 90 minus A. Cos 90 minus A is sine A. So sine 42 minus sine 42 is 0. So my dear students, question number 1, evaluate. I have done question number 1, question number 3. You can do question number 2 and question number 3. Now let me try question number 7. If you find it very difficult, you can follow my YouTube channel and you can comment and you can give suggestion to me to do all the sums. I'll do it for you. But for the time being, I'm doing you question number 1, question number 7. Cot 54 degree by tan 36 degree plus tan 20 degree by cot 70 degree minus 2. Keeping tan 36 degree constant, I'm converting cot 54 into cot 90 minus 36. 90 minus 36 is 54. So this becomes the formula of cot 90 degree minus angle A. Similarly like that, I'm keeping cot 70 degree fixed. Tan 20 degree I'm converting into tan. 90 minus 70 is 20. So this becomes tan 90 degree minus angle A. So here cot 90 minus angle A is tan A. Tan 90 minus A is cot A. So here numerator and denominator remains the same. Numerator and denominator remains the same. If you cancel it, it is 1. If you cancel it, it is 1 minus 2. 1 plus 1 is 2. 2 minus 2 is 0. In my next video, I will show you all the sums of exercise 8.3. You continue to follow my YouTube channel and I will show you how to calculate the height and distance also in the next video.